All right, guys, so we were talking about solving one-step equations in our last lesson. Now we're going to complicate things a little bit, but it shouldn't be too much harder. We're going to be looking at how to solve two-step equations now. So that means that it's going to take two steps to isolate the variable to figure out what the variable is supposed to equal. So we're going to kind of just walk through. A lot of this is going to be very similar to what we talked about in the first lesson. So this first part should be a lot of review, but it says to undo addition or subtraction, we're going to use the inverse operation to do that. So we're going to be using the inverse of addition, which is subtraction, and the inverse of subtraction, which is addition, to undo that operation, right? Undo multiplication or division. So here we're undoing multiplication or division with the inverse operations. So these two undo each other. Our task is to isolate, again, the variable, which is no different than what we did with one-step equations. And then in the end, we can always go back and check in our answer by plugging in our solution with the variable. Okay, so we're going to look at these models that we have right here. And these models can help us write an equation, but also solve an equation. So if I look at this equation, I can combine things that are the same or alike. So I have two really long rectangles, and those are representing x's. So if I write an equation here, this represents 2x, and then they added on to this by adding smaller rectangles here, which would be plus 1, 2, 3, 4. So each of those represented one whole, so I have 4 wholes. And then so we can imagine, if you remember, that this means that this is balanced. So there is some balance that is happening here. All right, and we know that whatever's on this side is going to have to equal what's on this side, and on this side we have 3 wholes. So something that I'm going to notice right away when I look at this equation is that this already has 4 wholes, and this goes down to 3 wholes. So in order to get from something bigger to something smaller, I'm probably going to have a negative answer. So let's look at what we can do. Remember what we're trying to do. Our objective here is the fact that we want to isolate, okay, our variable. So x here is our variable, and we're trying to get x isolated. So we need to get rid of these here, okay? So we need to get those to go away. So in order to get these to go away, if I just take them off or subtract the 4, I'm no longer balanced in my hanger diagram. So I also have to subtract the 4 from this side. And now I'm going to go 1, 2, 3. That got me to 0. And then I'm going to end up with a negative 1. I'm going to end up in the negative 1 range. Right? So now I have 2x is equal to negative 1. But I still haven't isolated my variable because I have the coefficient of 2 attached to it. So to undo multiplication, I'm going to have to divide, and I'm going to divide by that 2, and 2 divided by 2 is going to be 1, and I'm going to divide this by 2. So then my answer ends up becoming x is equal to negative 1/2, right? So looking over here again, we have another diagram. We can see that we can combine like terms. So I have 3 x's. They added 2 1s to it, so the value of those two together is 2. And then on this side, remember we're balanced again, that balanced hanger diagram, I have 8. Right, so my goal here is to get this x all by itself. So the first thing I need to do, if I divide by 3 right here, it doesn't make a lot of sense. The first thing I need to do is get rid of this plus 2. Okay, so the first thing I need to do is to get those to go away. So I'm going to subtract 2, and those are going to go away. But to keep it balanced, I have to subtract 2 from this side as well. And then I'm left with 3 x's on this side. And then I'm left with 6 on this side. And 8 minus 2 gives me my 6. All right, so now I just want this x by itself. So I'm going to have to get rid of this coefficient. So I need to divide by 3. And I'm going to divide this side by 3. So this 3 and this 3, 3 divided by 3 is 1. So I'm going to be left with 1x. And that is going to equal 6 divided by 3, which is 2. So these are my answers for my variables. That's what x equals. All right, so we are going to go through and we're going to solve each two-step equation. And then we're going to choose a few of them, but we're going to prove that our answer is correct by plugging in the information. All right, so let's rock and roll. Here we have two-step equation. I want to get the k by itself, okay? Right now, this is attached to this, so I can get rid of what's not attached to the k first. So I'm going to get rid of the minus 10. So to get rid of a positive 10, I'm going to subtract 10, and I'm going to do that to both sides. And then I'm going to be left with 3 k's that are positive, and that's going to end up equaling 12. Now I still want this k by itself. I am not done because this 3 is attached to it. So I need to divide by 3, 12 divided by 3. So I'm left with 3 divided by 3 leaves me with 1k, and that's going to end up equaling 12 divided by 3, which is 4. So in order to check, I can go 10 plus 3, and I'm going to replace that k with the 4, and I'm going to say is equal to 22. Now I have 10 plus 12 is equal to 22, and 22 is equal to 22. Therefore, I know that this is a balanced equation, right? So that's my way that I can check, yes, it worked. Okay, let's go to this side. This time we have our answer or our difference because it's a subtraction problem first. So I need to know that I need to get the p or the variable by itself. So the first thing I'm going to do is get rid of what's not directly attached to the p. I'm going to get rid of this negative 5. So the inverse, to undo that subtracting 5, I'm going to use the inverse, which is adding 5. And to keep it balanced, I'm going to add 5 to this side. And I'm going to end up with 24 is equal to 4p. Now to get rid of this coefficient that's attached to my variable, I'm going to divide by 4. And I'm going to divide by 4 on this side. I divided because the operation happening between the two of these was multiplication, right? So I'm going to be left with 4 divided by 4 is going to leave me with 1p. Okay, and then 24 divided by 4 is going to equal 6, right? I can check this by saying 19 is equal to 4 times 6 minus 5. 19 is equal to 24 minus 5, and then therefore 19 is equal to 19, and I know my answer is correct. Okay, so now we're going to move over to this one. This one's a little bit different. Here we had multiplication with the coefficient. This time our coefficient is dividing. But the first thing we need to do is to get rid of this right here. So we want to get the r by itself. Our goal is to figure out what r is equal to. Okay, but we got to get rid of this first. So this is subtracting 8. So to undo the subtraction, I'm going to add 8. Okay, and then I'm going to get 16 plus 8. So I'm going to be left with r over 2 is equal to 16 plus 8 is going to end up giving me 24. So this is saying some number divided by 2 is going to equal 24. Well, to get rid of this division, the inverse of my division is going to be to multiply by the denominator, which is 2. And then I'm going to multiply by the denominator, which is 2. This 2 divided by 2 is going to leave me with 1r, and then 24 times 2 is going to end up leaving me with 12. Oh, not 12. This is why I brought my eraser, guys, because math is full of mistakes. It would have been 12 if I was dividing, but I was multiplying each side. So 24 times 2 is going to give me 48. I didn't pay attention to the fact that I had boxes down here to check, but let's go ahead and check this one really quickly. We can say that 48 divided by 2, so I replaced my r with my 48 divided by 2, minus 8 is equal to 16. That leaves me with 24 minus 8 is equal to 16. And 16 is equal to 16. So my solution is correct because they're balanced or equal. Your practice for today is going to look like this sheet right here. And I added some comments over here. I am giving you guys on Edulastic, it's a 30-minute timer. So your 30-minute timer is going to go, and after 30 minutes, time is going to be up. So I want you super focused, but I want you super practicing. If you get to the end of it and you totally bombed it, you can certainly send me an email and I can reassign it to you. But I really want you focused in just spending 30 minutes on these 12 questions. Shouldn't take you much more than that. Right, guys? Good luck.